Section 6, day 2, talks about families of functions that we started with day 1. Just a quick reminder for you, y equals x squared, that's letter A, is the U-shaped graph. Those are quadratics. Y equals the absolute value of x are the V-shaped graphs. And then letter C, of course, is the line, y equals x. We did translations already, which are vertical and horizontal slides. We're going to talk about reflections, stretches, and compressions today. A reflection is a flip. So if you took something, like if you look in a mirror and you look at what you see versus what is actually there, it's completely flipped from the reality. In order to do that in math, we make it the opposite by negating. If you want a reflection in the y-axis, you need to negate x. If you want a reflection in the x-axis, you need to negate y, which is easy to remember because, again, it's opposite. You make opposite the opposite variable. So example 1, let g of x be a reflection of f of x equals negative 2x plus y in the y-axis. What is a function rule for g of x? So they want us to write a function rule for g of x, which means when I'm done, it's going to be g of x equals. Now, we're originally starting with 2x plus 1, and we want it to be a reflection specifically in the y-axis, which means I need to negate x. Wherever the x is, that needs to be negated. So I'm just going to throw a negative right in front of the x term and not change anything else. And I'm all done. Letter B, let h of x be a reflection of k of x equals negative 4x minus 2, again, in the y-axis. That means all I'm doing is changing the sign on x. So the new function is supposed to be h of x. I'm only going to change the sign on the x term. It was negative, so it's now going to be positive. The 2 that was minus is still minus. Letter C, let f of x be a reflection of g of x equals 2x plus 1 in the x-axis. Okay, I'm going to give you a shortcut on this one. If you wanted to reflect on the y-axis, you have to negate x. If you want a reflection on the x-axis, negate everything. Every term gets a negative for the x-axis. So in letter C, they want this to be a reflection on the x-axis. Change every sign. So my new function will be f of x equals a negative 2x minus 1. I changed all signs. All signs is a reflection in the x-axis. Letter D, let h of x be a reflection of k of x equals negative 4x minus 2 in the x-axis. A reflection in the x-axis negates absolutely everything. So I need to call it h of x. The negative 4x will turn positive. The negative 2 will turn positive. Pause the videos as needed to do the you try it. Stretches and compressions are the last part of transformations. A stretch multiplies all values by a number bigger than 1, and a compression reduces them by a value that's between 0 and 1. So here's what you need to know. Stretches are bigger than 1. Compressions are between 0 and 1. And you're going to do this. It says you do all y values, but in order to do that, you actually do it to the x term, so out front. They want you to write an equation for each transformation of y equals x. So y equals x is what we're starting with. To show a vertical compression by a factor of 1/6, I literally just write y equals 1/6 x. I do want to point out, even though they called it a compression, we know that it is because 1/6 is a value between 0 and 1. Letter B, they want a compression by a factor of 1/2. That's y equals 1/2 x. Letter C, a vertical stretch by a factor of 5. We know it's a stretch because 5 is bigger than 1. It's y equals 5x. And letter D, a vertical stretch by a factor of 8 is y equals 8x. You know y equals mx plus b. The values we just added there are the slope. So stretches and compressions take a graph vertically and either pull it or compress it. And when that happens, the graph ends up becoming steeper or flatter, depending on whether it was a stretch or a compression. In each of the u-triads, do not forget to put the x squared part. These are all quadratics. They all need an x squared. In today's lesson, we learned how the parent function is affected by both reflections and stretches and compressions. You might want to make sure you're okay with the fact that stretches are part of that as well.